Okay. Hi. Okay. So let's go over the restricted Boltzmann machine, which has been formulated by Hinton, Nobel Prize in Physics 2024, and in 1982, and is also called with the RBM more briefly. So the first thing now we want to see what is the architecture. Architecture. And the Boltzmann machine basically has one layer of visible neurons, V1, V2, V3, Vn is one layer. This is basically the visible neurons. And then we have another layer of hidden neurons, H1, H2, H3, HM. And so these are basically the hidden neurons. And they cross-talk to each other only through cross-talking. There is no communication of neurons within each layer. So within each layer, the neurons don't interact, and similarly for the hidden layer. So that's why now this is called restricted Boltzmann. And the usually now the we what this is the first example, first algorithm for generative AI, because we can given a data set, imagine that in our case they are images. We have basically an array of num images times size times 3 the channel. Imagine that we have an array of several images, and which of course each image then it is reshaped as a huge long vector of visible neurons, V1, Vn. And what is the size of n? N is going to be basically the size of the image times size times 3. And the role of the hidden layer is to basically learn hidden features of the data set that they're basically seen through the visible layer. The energy associated with the Boltzmann machine, it is given by sum over J of W I J H VI hj minus summation over I of bi vi minus summation over j of cj hj. So, and of course, here now remember now V is the list of all the visible nodes, and H is the list of all the hidden nodes. Okay, so here we have this this weight matrix. This expression can also be written in matrix form as V transpose times W times H minus B vector transpose times V minus C vector transpose times C. And the important role is given by this weight matrix, which is going to have the following size. Is going to have here the number of visible nodes. Here we have number of hidden neurons, M, hidden dimension. And here we have the N dimensions, which is basically the visible. So what happened, I mean, the columns of this weight matrix have the same dimensions of the images and represent hidden features learn that the machine learns from training. Okay, so and we already have seen that actually I can do it here. The associated probability of V and H is basically given by the Boltzmann distribution. Divided by, is basically the exponential of minus beta, where beta is the inverse of temperature. And Z is basically, the partition function. And so what happened is that the training process consists of learning these matrices, the matrix, the weight matrix, and the bias vectors from the data using training algorithm that has been devised by Hinton. And then once we have the weights and the bias vectors, we can sample from the Boltzmann distribution and generate new images that have the same statistical property as the original training data, the original statistical distribution of the original data. Okay,